Hello out there, welcome to this tutorial on geometry of a straight line. This is part 7 of this tutorial. Check the description section of this video on our YouTube channel to get the link to other parts. So in this video, we'll be looking at problems involving quadrilateral. The coordinates of the vertices of quadrilateral PQRS are P 0, 4, Q -3, -1, R -2, -4, and S 1, 1. A. Show that the quadrilateral is a parallelogram. B. Find angle QPS and hence the area of the quadrilateral. To solve this problem, we're going to make a sketch, though not on the Cartesian plane of the quadrilateral. In that case, we are going to make it look like the parallelogram we are to show it is, because definitely it is a parallelogram. But how we show it is the key to the solution. So we have the parallelogram. This is a PQRS. Remember, it must follow in alphabetical order and in any direction. So it could be clockwise, it could be anti-clockwise. So whichever you choose. And one of the properties we're going to use to show that the quadrilateral is a parallelogram is that a parallelogram has two pairs of parallel sides. That is to say, we're going to show that PQ is parallel to SR or RS and PS is parallel to QR. And how do we show by geometry of a straight line that two lines are parallel? We have to show that they have the same gradient, which means we are going to be finding the gradients of all the lines of the parallelogram. So starting with line PQ, we know that the formula for gradient is y2 minus y1 over x2 minus x1. So we now have the gradient for PQ, where we label P to be x1, y1, and Q to be x2, y2. So our y2, which is -1 minus y1, that's -4, over our x2 is -3, then -0. So this giving us -5 over -3. And finally, we have it as 5 over 3. Then we go for QR. For QR, we still find the gradient M, where our Q is going to be x1, y1, our R will be x2, y2. So y2 minus y1, -4 minus 1. Our y2 is -1. That's going to be minus, and that will give us +1 over x2 is -2 minus x1, that is -3. That one also we change to +3. So simplifying, we have a -3 over 1, and -3 over 1 gives -3. So we are done with QR. We then go for RS, still maintaining our M for the gradient. Our R is going to be x1, y1, and our S is going to be x2, y2. We have our y2 to be 1, so we have 1 minus -4 will give us +4 over x2 is also 1 minus -2 will give us a +2. So 1 plus 4 gives 5 over 3. So that's all for RS. We then go for PS. So still calculating the gradient. Our P is going to be x1, y1, and our S gives x2, y2. So y2 is 1 minus 4 over x2 is 1 minus 0. So this is giving us negative 3 over 1, and then that gives negative 3. So we've gotten all the gradients for all the lines. So we can now inspect that PQ has the same gradient with RS 5 over 3, which means PQ is parallel to RS. So these ones are parallel, and also QR is parallel to PS since they have the same gradient. QR is parallel to PS. We now conclude that the quadrilateral is a parallelogram. And that's all for A. We then go for B. So for B, we are to calculate angle QPS. QPS, this angle here, is what we are to calculate. So which means we need the gradient of PQ and what? PS. We've already calculated the gradient to be 5 over 3 and this one to be negative 3. So you still remember the formula for calculating an acute angle. This is an acute angle. So we have a tan theta to be m1 minus m2 over 1 plus m1 m2 with the absolute value. So we have m1 to be 5 over 3 and m2 to be negative 3. So that tan theta, which is the angle QPS, is equal to absolute value of 5 over 3 minus negative 3 over 1 plus, we have negative 3 times 5 over 3. So in putting this in our calculator, we have it as 1.167, and our theta then is tan inverse of 1.167, which gives 49.41 degrees. So here, to calculate the area of a parallelogram, it is AB sine theta. So we are going to take PQ as A and at the same time take PS as B, which means we are going to find the length PQ and length PS. So we still have our formula for calculating length. So starting with A, remember we are taking this as x2, which is minus 3 minus 0 all squared, then plus negative 1 minus 4 all squared, and that will give us a square root of 9 plus 25, which gives square root of 34. Then for B, so we are going to have it as square root of 0 minus 1 all squared, then plus 4 minus 1 all squared. So this is equal to 1 because negative 1 squared is 1. 4 minus 1 is 3. 3 squared is 9. So 1 plus 9, and that gives root 10. We then go ahead to calculate our area, which is root 34 times root 10. That is AB, then sine multiplied by sine 49.41 degrees. Pressing this on our calculator, we have the area of the parallelogram to be 14.0 square units. And that's all for this tutorial. I hope you enjoyed it. Thank you for watching. Remember to check the description section of this video on our YouTube channel to get the link to other parts of geometry of a straight line. Until we come your way again, goodbye.